Hello and welcome to the 20th and the final lecture of this series, that is MD Simulation Resources and Conclusion. So if you have followed this course throughout, and if you have gone through all the lectures, so I would like to thank you and congratulate you because you have learned about so many things: molecular docking software and servers, a little bit detailed discussion on molecular dynamics theory. You have learned about so many software about MD, how to set up and visualize MD, and how to particularly run MD simulation through LAMS, and how to create your system from scratch or from server, and how to analyze the data in LAMS. So in this lecture, I will give you a kind of a formal conclusion to this series, and I will give you some information about good resources on MD simulation. So previously, we have shown you an EvoCity tutorial on how to perform an uniaxial tension on aluminum. And when it comes to MD simulation resources, where do I learn from? A lot of the times, students are stuck thinking about which should be my square one to learn conveniently and step-by-step tutorials. So you can use these two resources. One is the EvoCity tutorial, and another one is Justin Lemku's tutorials. EvoCity is generally used for material science related projects, and Justin Lemku's tutorial shows so many biomolecular projects step by step, and he uses VMD and possibly GROMACS. And I cannot emphasize this more, that LAMS and GROMACS documentation are very detailed, and you can virtually find explanation of everything if you just search for it. Let's say you search for LAMS units. If you come up with an input script for someone else and you don't know what this input script means, my suggestion is to go through every line and search for every line. Let's say units, you search for LAMS units. You will find a very detailed explanation of what units means and how to, and go through all the other commands to, and after you practice with it and apply this to real world projects, you will get a very good idea. And so goes for GROMACS or VMD documentation. Dr. Justin Lemku's documentation, or some software documentation also, like for VMD. They have very detailed documentation and tutorials on how to perform MD simulation on biomolecular systems. Now, generally the tutorials are made for small systems so that you can learn from them and run them actually in your local PC. But these are actually true for only small systems containing just a small protein or just a few thousand atoms, which can be run in your local server or PC. Generally, computation-intensive labs are facilitated with university cluster computers or supercomputers. They have access to these HPC, that is high performance computational units, that they have to pay for and purchase so that they can run large set of simulations, which facilitates parallel computation and massive computational power. If not, sometimes there are other options like buying these computational packages from third party like Google or Amazon. So now you know how to run these simulations, how to run these simulations at large scale in university setting or lab setting, and what to do now. You have a very technical and high level introduction on MD simulation. Now your task is to practice and apply this in real world projects. And if you get stuck, feel free to ask any expert, and also feel free to go through documentation. My suggestion is to go through errors, go through forums, and go through discussions. You may wonder that you are possibly facing a particular problem first in the world, but if you search for forums, you will see that possibly your answer is given 10 to 12 years ago in the molecular dynamics simulation forums. So my suggestion will be to really go through the fundamentals, understand the theories, and apply those in real world projects. And when get stuck, go through the forums and the documentations of the software so that you can overcome your problems. And always maintain good practice in MD in terms of research. Although it is totally computational, but all the ethics and regulations and other research aspects are applicable for MD simulation as it is applicable for experimental approaches. So good luck for you and thank you. Please feel free to like, comment, share, and subscribe.